Hi everybody. Today's topic is constants of a transmission line. This topic is related to power system, transmission and distribution. At the end of this video, you will be able to explain the need of constants or parameters of a transmission line and constants of a transmission line. Before going to the topic, at first I would like to give a brief note on power systems by the consideration of single line diagram. Power system means power is generated at the generating stations and is transferred to the consumer premises through a large amount of network called transmission and distribution system. In this entire system, now I am concentrating on the transmission part, which is comprising of parameters or constants R, L, G and C, that is resistance, inductance, conductance and capacitance. The need of these constants of a transmission line are: in order to evaluate transmission efficiency, economy and by these determine the real transmission line losses, we must know the transmission line parameters. It is also called as constants of a transmission line: resistance, inductance and shunt combination of conductance and capacitance. These parameters are symbolized as R, L, G and C respectively. Of these four parameters R, L, G and C, the parameters R and G are least important because they do not affect much the total equivalent impedance of the line and the transmission capacity. That is, the performance of a transmission line depends to a considerable extent upon these constants. Then coming to the topic, constants of a transmission line. A transmission line has resistance, inductance, conductance and capacitance uniformly distributed along the whole length of the line. Observe this circuit diagram consisting of these parameters: resistance and inductance along with the conductance and the capacitance. Regarding the resistance, it is the opposition of line conductors to current flow. The resistance is distributed uniformly along the whole length of the line. However, the performance of a transmission line can be analyzed conveniently if distributed resistance is considered as lumped. Regarding the inductance, when an alternating current flows through a conductor, a charging flux is set up which links the conductor. Due to these flux linkages, the conductor possesses inductance. Mathematically, inductance is defined as a flux linkages per ampere. Therefore, inductance L is equal to psi by I Henry. Psi tends to the flux linkages in Weber turns, I tends to the current in amperes. Like as resistance, inductance is also uniformly distributed along the length of the line. For the convenience of analysis, it is also consider it as lumped. Then coming to the capacitance, we know that any two conductors separated by an insulating material constitute a capacitor. As any two conductors of an overhead transmission line are separated by air, which acts as an insulation, therefore capacitance exists between any two overhead line conductors. The capacitance between the conductors is the charge per unit potential difference. That is, capacitance C is equal to Q by V farads. Q tends to the charge on the line in coulombs, V tends to the potential difference between the conductors in volts. The capacitance is uniformly distributed along the whole length of the line and may be regarded as a uniform series of capacitance connected between the conductors. When an alternating voltage is impressed on a transmission line, the charge on the conductors at any point increases and decreases with the increasing and decreasing of the instantaneous value of the voltage between conductors at that point. The result is that a current flows between the conductors called as charging current. This charging current flows in the line even when it is open circuited. That means supplying no load. It affects the voltage drop along the line as well as the efficiency and power factor of the line. Important points regarding the constants of a transmission line are: series resistance is very important in transmission efficiency evaluation and in economic studies. Power transmission capacity of a line is mainly governed by the series inductance. Shunt capacitance causes a charging current to flow in the line and is assumed importance in medium and long lines. For short transmission, shunt capacitance is neglected. Shunt conductance accounts for leakage currents flowing across the insulators and ionized pathways in the air. Shunt conductance not considered for overhead transmission lines. The conclusion of this topic are: for the evaluation of transmission efficiency, economy and real transmission losses, we must know the transmission line parameters R, L, G and C. Regarding the resistance, it is the opposition of line conductors to current flow. Regarding the inductance, an alternating current flows through a conductor. A changing flux is set up which links the conductor due to these flux linkages. Therefore, inductance L is equal to psi by I Henry. And the capacitance, any two conductors separated by an insulating material constitutes a capacitance. The capacitance C is equal to Q by V farads. These are the important parameters or the constants for the transmission line. Thank you.